Red Hat Enterprise Linux 9, managing storage devices. We are going to see all these things. Overview of available storage options, local storage overview, remote storage overview, GFS2 file system overview, persistent naming attributes, persistent attributes for identifying file systems and block devices, UDEV device naming rules, obtaining the device links values for an existing device. Disk partitions, overview of partitions, comparison of partition table types, MBR disk partitions, extended MBR partitions, MBR partition types, GOID partition table, partition types, partition naming scheme, mount points and disk partitions. Getting started with partitions, creating a partition table on a disk with parted, viewing the partition table with parted, creating a partition with parted, setting a partition type with a disk, resizing a partition with parted, removing a partition with parted. Strategies for repartitioning a disk, using unpartitioned free space, using space from an unused partition, using free space from an active partition, destructive repartitioning, non-destructive repartitioning, configuring an iSCSI target, installing target CLI, creating an iSCSI target, iSCSI backstore, creating a file IO storage object, creating a block storage object, creating a pSCSI storage object, creating a memory copy RAM disk storage object, creating an iSCSI portal, creating an iSCSI LUN, creating a read-only iSCSI LUN, creating an iSCSI ACL, setting up the challenge handshake authentication protocol CHAP for the target, removing an iSCSI object using target CLI tool, configuring an iSCSI initiator, creating an iSCSI initiator, setting up the challenge handshake authentication protocol for the initiator, monitoring an iSCSI session by using the iSCSI ADM utility, DM multipath overrides of the device timeout, using fiber channel devices, rescanning fiber channel logical units after resizing a LUN, determining the link loss behavior of device using fiber channel configuration files. Overview of NVMe over fabric devices. Configuring NVMe over fabrics using NVMe or RDMA. Setting up an NVMe or RDMA controller using config-fs. Setting up the NVMe or RDMA controller using NVMe TCLI. Configuring NVMe or RDMA host. Next steps. Configuring NVMe over fabrics using NVMe or FC. Configuring the NVMe host for Broadcom adapters. Configuring the NVMe host for QLogic adapters. Next steps. Configuring NVMe over fabrics using NVMe or TCP. Configuring an NVMe or TCP host. Connecting the NVMe or TCP host to the NVMe or TCP controller. Configuring NVMe host authentication. Configuring an NVMe or TCP host using TLS with pre-shared keys. Enabling multipathing on NVMe devices. Native NVMe multipathing and DM multipath. Enabling DM multipath on NVMe devices. Enabling native NVMe multipathing. Setting up a remote diskless system. Preparing environments for the remote diskless system. Configuring a TFTP service for diskless clients. Configuring a DHCP server for diskless clients. Configuring exported file system for diskless clients. Reconfiguring a remote diskless system. Troubleshooting common issues with loading a remote diskless system. Getting started with swap. Overview of swap file space. Recommended system swap space. Creating an LVM2 logical volume for swap. Creating a swap file. Creating a swap volume by using the storage RHL system role. Extending swap on an LVM2 logical volume. Reducing swap on an LVM2 logical volume. removing an LVM to logical volume for swap, removing a swap file, configuring fiber channel over Ethernet using hardware FCOE HBAS in RHEL, setting up an FCOE device, managing tab devices, types of tab devices, installing tape drive management tool, tape commands, writing to rewinding tape devices, writing to non-rewinding tape devices, switching tape head in tape devices, restoring data from tape devices, erasing data from tape devices, managing RAID overview of RAID types, RAID levels and linear support, supported RAID conversions, RAID subsystems, creating a software RAID during the installation, creating a software RAID on an installed system, creating RAID in the web console, formatting RAID in the web console, creating a partition table on RAID by using the web console, creating partitions on RAID by using the web console, creating a volume group on top of RAID by using the web console, configuring a RAID volume by using the storage RHL system role, extending RAID, shrinking RAID, converting a root disk to RAID 1 after installation, creating advanced RAID devices, setting up email notifications to monitor a RAID, replacing a failed disk in RAID, repairing RAID disks, encrypting block devices using LUKS, Lux, Lux disk encryption, Lux version in RHL, options for data protection during Lux2 re-encryption, encrypting existing data on a block device using Lux2, encrypting existing data on a block device using Lux2 with a detached header, encrypting a blank block device using Lux2, configuring the Lux passphrase in the web console, changing the Lux passphrase in the web console, creating a Lux2 encrypted volume by using the storage RHL system role, using NVDIM persistent memory storage. The NVDIM persistent memory technology, NVDIM interleaving and regions, NVDIM namespaces, NVDIM access modes, installing NDCTL, creating a sector namespace on an NVDIM to act as a block device, reconfigure an existing NVDIM namespace to sector mode, creating a new NVDIM namespace in sector mode, creating a device DAX namespace on an NVDIM, NVDIM in device direct access mode, reconfiguring an existing NVDIM namespace to device DAX mode, creating a new NVDIM namespace in device DAX mode, creating a file system DAX namespace on an NVDIM, NVDIM in file system direct access mode, reconfiguring an existing NVDIM namespace to file system DAX mode, creating a new NVDIM namespace in file system DAX mode, creating a file system on a file system DAX device, monitoring NVDIM health using Smart, detecting and replacing a broken NVDIM device, discarding unused blocks, types of the block discard, operations, recommendations, performing batch block discard, enabling online block discard by using the storage RHEL system role, enabling periodic block discard, removing storage devices, rate removal of storage devices, removing block devices and associated metadata, setting up Stratis file systems, components of a Stratis file system, block devices compatible with Stratis, supported devices, unsupported devices, installing Stratis, creating an unencrypted Stratis pool, creating an unencrypted Stratis pool by using the web console, creating an encrypted Stratis pool using a key in the kernel key ring, creating an encrypted Stratis pool using Clevis, creating an encrypted Stratis pool by using the storage RHL system role, creating an encrypted Stratis pool by using the web console, renaming a Stratis pool by using the web console, setting over provisioning mode in Stratis file system, binding a Stratis pool to NBDE, binding a Stratis pool to TPM, unlocking an encrypted Stratis pool with kernel keyring, unbinding a Stratis pool from supplementary encryption, starting and stopping Creating a static file system. Creating a file system on a static spool by using the web console. Mounting a static file system. Setting up non-root static file systems in etc FSTab using a systemd service. Extending a static spool with additional block devices. Adding block devices to a static spool. Adding a block device to a static spool by using the web console. Monitoring static file systems. Displaying information about static file systems. Viewing a static spool by using the web console. Using snapshots on static file systems. Characteristics of static snapshots. Creating a static snapshot. Accessing the content of a static snapshot. Reverting a static file system to a previous snapshot. Removing a static snapshot. Removing static file systems. Removing a static file system. Deleting a file system from a static spool by using the web console. Removing a static spool. Deleting a static spool by using the web console. Providing feedback on redundant documentation. We appreciate your feedback on our documentation. Let us know we can improve it. Submitting feedback through Jira account required. Log into the Jira website. Click Create in the top navigation bar. Enter a descriptive title in the summary field. Enter your suggestion for improvement in the description field. Include links to the relevant parts of the documentation. Click Create at the bottom of the dialog. Create summary description. Create. Overview of available storage options. There are several local, remote, and cluster-based storage options on RHEL9. Local storage implies that the storage devices are either installed on the system or directly attached to the system. With remote storage, devices are accessed over LAN, the internet, or using a fiber channel network. The following high-level Red Hat Enterprise Linux storage diagram describes the different storage options. High-level Red Hat Enterprise Linux storage diagram. User, applications, file systems, volume management functions, raw device partitioning, device drivers, direct attached or internal SSD or internal HDD, persistent memory NVDIMM, system resident physical storage media, NIC or HPA cards or RAID cards, RHL host, external SAN or NAS storage, external SAN or NAS storage, persistent memory direct access path, storage target modes NFS or CIFS or iSCSI, external systems, local storage overview. Red Hat Enterprise Linux 9 offers several local storage options. Basic disk administration using parted and fdisk. You can create, modify, delete, and view disk partitions. The following are the partitioning layout standards. Master boot record MBR. It is used with BIOS based computers. You can create primary, extended, and logical partitions. GUID partition table GPT. It uses global unique identifier GUID and provides unique disk and partition GUID. Storage consumption options, non-volatile, dual inline memory modules, NVDIMM management. It is a combination of memory and storage. You can enable and manage various types of storage on NVDIMM devices connected to your system. Block storage management. Data is stored in the form of blocks where each block has a unique identifier. File storage. Data is stored at file level on the local system. This data can be accessed locally using XFS default or ext4 or over a network by using NFS and SMB. By using NFS and SMB, logical volumes, logical volume manager LVM. It creates logical devices from physical devices. Logical volume LV is a combination of the physical volumes PV and volume groups VG. Volume data optimizer VDO. It is used for data reduction by using deduplication, compression, and thin provisioning. Using LV below VDO helps in extending a video volume, spanning video volume over multiple devices. Logical file systems XFS, the default RHL file system. ext for a legacy file system. Status Status is a hybrid user and kernel local storage management system that supports advanced storage features. Remote storage overview. The following are the remote storage options available in RHEL9. Storage connectivity options iSCSI. RHEL9 uses the target CLI tool to add, remove, view and monitor iSCSI storage interconnects. FC. Fiber channel FC. RHEL9 provides the following native fiber channel drivers. LPFC, QLA2XXX, ZFCP, Non-Volatile Memory Express, NVMe, an interface which allows host software utility to communicate with solid-state drives. Use the following types of fabric transport to configure NVMe over fabrics. NVMe over fabrics using remote direct memory access, NVMe or RDMA. NVMe over fabrics using fiber channel NVMe/FC, NVMe over fabrics using TCP NVMe/TCP, device mapper multipathing DM multipath, allows you to configure multiple input or output paths between server nodes and storage arrays into a single device. These input or output paths are physical SAN connections that can include separate cables, switches and controllers. Device mapper multipathing DM multipath allows you to configure multiple input or output paths between server nodes and storage arrays into a single device. These input or output paths are physical SAN connections that can include separate cables, switches and controllers. Network file system NFS SMB. GFS2 file system overview. The Red Hat Global File System 2, GFS2 Global File System 2. File system is a 64-bit symmetric cluster file system which provides a shared namespace and manages coherency between multiple nodes sharing a common block device. A GFS2 file system is intended to provide a feature set which is as close as possible to a local file system while at the same time enforcing full cluster coherency between nodes. To achieve this, the nodes employ a cluster-wide locking scheme for file system resources. This locking scheme uses communication protocols such as TCP or IP to exchange locking information. In a few cases, the Linux file system API does not allow the clustered nature of GFS2 to be totally transparent. For example, programs using POSIX logs in GFS2 should avoid using the get, getlk function, since in a clustered environment, the process ID may be for a different node in the cluster. In most cases, however, the functionality of a GFS2 file system is identical to that of a local file system. The Red Hat Enterprise Linux Resilient Storage add-on provides GFS2 and it depends on the Red Hat Enterprise Linux High Availability add-on to provide the cluster management required by GFS2. The GFS2.ko kernel module implements the GFS2.ko kernel module implements the GFS2 file system and is loaded on the GFS2 cluster nodes. To get the best performance from GFS2, it is important to take into account the performance considerations which stem from the underlying design. Just like a local file system, GFS2 relies on the page cache in order to improve performance by local caching of frequently used data. In order to maintain coherency across the nodes in the cluster, cache control is provided by the glog state machine. Additional resources configuring GFS2 file systems. Chapter 2 Persistent Naming Attributes. The way you identify and manage storage devices ensure the stability and predictability of the system. RHL 9 uses two primary naming schemes for this purpose: traditional device names and persistent naming attributes. Traditional device names. The Linux kernel assigns traditional device names based on the order in which they appear in the system or their enumeration. For example, the first SATA drive is usually labeled as /a//sta, the second as /a//stb, and so on. While these names are straightforward, they are subject to change when devices are added or removed. The hardware configuration is modified or the system is rebooted. This can pose challenges for scripting and configuration files. Furthermore, traditional names lack descriptive information about the purpose or characteristic of the device. Persistent naming attributes. Persistent naming attributes. Persistent naming attributes PNAs are based on unique characteristics of the storage devices, making them more stable and predictable when presented to the system, even across system reboots. One of the key benefits of PNAs is their resilience to changes in hardware configurations, making them ideal for maintaining consistent naming conventions. In using PNAs, you can reference storage devices within scripts, configuration files, and management tools without concerns about unexpected name changes. Additionally, PNAs often include valuable metadata such as device type or manufacturer information, like combination of vendor, model name, and serial number, enhancing their descriptiveness for effective device identification and management. PNAs are eventually used to create device links in /save/disk directory to access individual devices. The way the device link names are constructed and managed is driven by UDEV rules. The following is a list of directories you can find in /save/disk. Directories with content that remain unique even after system restart. By ID based on hardware attributes with the vendor or model or serial underscore string combination. By path, asterisk based on physical hardware placement for devices or disks physically attached to a machine. This is the slot or port where they are connected physically to the host bus on the motherboard. However, for disks or devices attached over a network, this contains a network address specification. By part label based on a label assigned to a device partition. These labels are assigned by the user. By part UUID based on a unique number in the form of UUID that is auto-generated. by UUID based on unique number in the form of UUID that is auto-generated directly with content that remain unique during the current system run but not after system restart by disk SEQ. Disk SEQ is a disk sequence number that starts at 1 when the system boots. It assigns this number to a newly attached disk and each one after that gets the next number in sequence. When the system reboots, the counter restarts at 1. Directories with content that are used specifically for device loops by loop ref, by loop inode, persistent attributes for identifying file systems and block devices. In RHEL9 storage, persistent naming attributes (PNAs) are mechanisms that provide components for consistent and reliable naming for storage devices across reliable system reboots, hardware changes, or other events. These attributes are used to identify storage devices consistently, even if the storage devices are added, removed, or reconfigured. PNAs are used to identify both file systems and block devices, but they serve different purposes. Persistent attributes for identifying file systems. Universally Unique Identifier UUID. UUIDs are primarily used to uniquely identify file systems on storage devices. Each file system instance has its own UUID assigned automatically, and this identifier remains constant even if the file system is unmounted, remounted, or the device is detached and reattached. Labels are user assigned names for file systems. While they can be used to identify and reference file systems, they are not as standardized as UUIDs. Since a user assigns the file system label, its uniqueness depends on their choice. Labels are often used as alternatives to UUIDs to specify file systems in configuration files. When you assign a label to a file system, it becomes part of the file system metadata. This label remains associated with the file system even if it is unmounted, remounted, or the device is detached and reattached. Persistent attributes for identifying block devices. Universally Unique Identifier UUID. UUIDs can be used to identify storage block devices. When a storage device is formatted, a UUID is often assigned to the device itself. Such UUIDs are usually generated and assigned to virtual block devices layered on top of other block devices, where the real devices are at the bottom level. For example, device mapper DM-based devices and their related subsystems such as logical volume manager LVM and crypt use UUIDs for device identification such as logical volume UUID LV, UUID and crypt UUID. Also, multiple device MD-based devices have UUIDs assigned. The virtual devices usually also mark the underlying devices with the component UUIDs. For example, LVM marks its underlying devices with a physical volume UUID, PV UUID, and MD marks its underlying devices with an MD component UUID. These UUIDs are embedded within the virtual block device metadata and they are used as persistent naming attributes. It allows you to uniquely identify the block device even if you change the file system that resides on it. UUIDs are also assigned for device partitions. Such UUIDs can coexist with other device IDs. For example, an STA device at the bottom of the device stack, which is identified by its vendor or model or serial number combination or WWID, can also have a PV UUID assigned by LVM. This is then recognized by LVM itself to build up the volume group VG or logical volume LV in a layer above it. Label or name labels or names can be assigned to certain block devices too. This applies to partitions which can have User assigned labels. Some of the virtual block devices like device mapper, DM based devices, and multiple device MD based devices also use names to identify devices. Worldwide Identifier WWID. WWID encompasses a family of identifiers which are global unique and they are associated with storage block devices or storage components in general. They are commonly used in enterprise level storage area networks SANs like Fiber Channel FC to identify a storage node. Worldwide node name WWNN or actual port or connection to a storage device on the node. Worldwide port name WWP and WWIDs ensure consistent communication between servers and SAN storage devices and help manage redundant paths to storage devices. Other types of devices may use a form of WWIDs too, like NVMe devices. These devices do not necessarily need to be accessed over a network or SAN, and they do not have to be enterprise level devices either. The WWID format does not follow a single standard. For example, SCSI uses formats such as NAAT10 and EUI. The NVMe uses formats such as EUI-64, NG, UUID, and UUID. Serial string. The serial string is a unique string identifier assigned to each storage block device by the manufacturer. It can be used to differentiate among storage devices and may be used in combination with other attributes like UUIDs or WWIDs for device management. Within UDEV rules and consequently in the /save/dis/by-id content, the short serial string typically represents the actual serial string as reported by the device itself, whereas serial string is composed of several components, usually bus type -vendor name underscore model name underscore short serial string. WWIDs and serial strings are preferred for real devices. For virtual devices, UUIDs or names is preferred. UDEV device naming rules. User space device manager UDEV subsystem allows you to define rules for assigning persistent names to devices. These rules are stored in a file with a .rules extension. There are two primary locations for storing the UDEV rules /usr/live/udev/rules.d directory contains default rules that come with an installed package. /etc/udev/rules.d directory is intended for custom UDEV rules. Note if a rule from USR live udev rules.d is modified, it will be overwritten by the rules file of the package during an update. Hence, any manual or custom rule should be added in /etc/udev/rules.d where it is retained until removed explicitly. Before use, udev rules from both directions are merged. If a rule in /etc/udev/rules.d has the same name as one in /usr/live/udev/rules.d, the one in the former takes precedence. The purpose of these rules is to ensure that storage devices are consistently and predictably identified even across system reboots and configuration changes. UDEV rules define actions to execute based on incoming events that notify about. The purpose of these rules is to ensure that storage devices are consistently and predictably identified even across system reboots and configuration changes. UDEV rules define actions to execute based on incoming events that notify about adding, changing, or removing a device. This also helps to collect values for the persistent storage attributes and direct UDEV to create /save content based on the collected information. The UDEV rules are written in human readable format using key value pairs. In the case of storage devices, UDEV rules control creation of symbolic links. in the /save/disk directory. These symbolic links provide user-friendly aliases for storage devices, making it more convenient to refer to and manage these devices. You can create custom UDEV rules to specify how devices should be named based on various attributes such as serial numbers, worldwide name, WWN identifiers, or other device-specific characteristics. By defining specific naming rules, you have precise control over how devices are identified within the system. To create a specific custom symbolic link in /dev for a device, see the UDEV 7 man page on your system. While UDEV rules are very flexible, it is important to be aware of UDEV limitations. Accessibility timing. Some storage devices might not be accessible at the time of a UDEV query. Event-based processing. The kernel can send UDEV events at any time, potentially triggering rule processing and link removal if a device is inaccessible. Processing delay. There might be delay between event generation and processing, especially with numerous devices, causing a lag between kernel detection and link availability. Device accessibility. External programs invoked by UDEV rules like BLKID might briefly open the device, making it temporarily inaccessible for other tasks. Link updates. Device name is managed by UDEV in /save/disk can change between major releases requiring link updates. The following table lists the symlinks available in /save/disk. Device type are non-persistent name, kernel name, persistent symlink names. Real devices NVMe non-volatile memory express /save/NVMe asterisk /save/disk/by-ed/NVMe WWID /save/disk/by-ed/NVMe model-serial_serial_NSID SCSI small computer system interface non-persistent name kernel name /save/st */save/sr persistent symlink name /save/disk/by-id/cs/by-id/wwn-wwn by /save/this/by-id/usp-vendor_model_serial-instance /save/this/by-id/IEEE 1394-IEEE 1394-IP-IP_address:/IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_IP_0 in angular bracket vendor_model_ID /save/this/by-id/SCSI-1 T10 _vendor_ID/this/by-id/SCSI-2/UI64_ID /save/this/by-id/SCSI-3/NAE_reg_EXT_by_ID /save/this/by-id/SCSI-3 NAE_reg_ID /save/this/by-id/SCSI-3 NAE_EXT_ID /save/this/by-id/SCSI-3 NAE_local_ID /save/this/by-id/SCSI-8 name capital S and angular bracket vendor_model_serial AT Advanced Technology Attachment or AT-API ATA Packet Interface /save/st */save/sr /save/this/by-id/AT model /this/by-id/WWN CCISS Compact Command Interface for SCSI-3 support /save/CCISS slash save slash this slash by hyphen id slash cciss hyphen model underscore serial slash save slash cciss slash cciss word IO virtual input output slash save slash vd asterisk slash save slash this slash by hyphen id slash word IO hyphen serial pmem persistent memory slash save slash pmem asterisk slash save slash this slash by hyphen id slash pmem hyphen uuid MMC multimedia card slash save slash MMC BLK asterisk slash save slash this slash by hyphen slash MMC hyphen name underscore serial memstick memory stick slash save slash MS BLK asterisk slash save slash this slash by hyphen slash memstick hyphen name underscore serial virtual devices device type loop non-persistent kernel name slash save slash loop asterisk persistent symlink names slash save slash this slash by hyphen loop hyphen inode id underscore loop underscore backing underscore device hyphen id underscore loop underscore backing underscore inode slash save slash this slash by hyphen loop hyphen ref id underscore loop underscore backing underscore file name dm device hyphen mapper slash save slash dm hyphen asterisk slash save slash mapper slash an angular bracket name slash save slash this slash by hyphen ad slash dm hyphen name slash save slash this slash by hyphen ad slash dm hyphen uuid slash save slash this slash by hyphen ad slash wwn hyphen wwn md multiple device slash save slash md asterisk slash save slash md slash dev name slash save slash this slash by hyphen ad slash md hyphen name slash save slash this slash by hyphen id slash md hyphen uuid hyphen uuid partitions either on top of a real or a virtual device any slash save slash this slash by hyphen part uuid slash uuid slash save slash this slash by hyphen part label slash date slash persistent symlink name hyphen part angular bracket number lvm tab PVs for logical volume manager physical volumes either on top of a real or a virtual device. Any slash save slash this slash by hyphen slash lvm hyphen pv hyphen uuid slash pv uuid. Obtaining the device links value for an existing device. You can obtain the value of the device links for an existing device from the current UDEV database. Prerequisite: the device is present and connected to the system. Procedure: list all the assigned device symbolic links. Dev links to the base kernel device node. Dev name under slash dev for an existing device. Procedure: list all the assigned device name symbolic links. Dev links to the base kernel device node. Dev name under slash dev for an existing device. So the command is udev adm info hyphen name slash dev slash nvme 0 n1 hyphen queries property hyphen property dev links hyphen value. I will execute this command. udev adm info hyphen name slash dev slash nvme 0 n1 hyphen query space property hyphen property ಸರಿಯಾಗಿ Dave links value. So slash save slash disk slash buy hyphen id nvme hyphen virtual VMware virtual NVMe disk VMware underscore NVMe underscore 0000 slash save slash disk slash buy hyphen disk SEQ slash 1 slash save slash disk slash buy path PC hyphen 000. PCI hyphen 0000 colon 0B colon 00.0 hyphen NVMe hyphen 1 slash save slash disk slash buy hyphen ID slash NVMe hyphen EUI dot 19F3BC 3B813B. Replace NVMe 0N1 with your device name. You can also obtain the base kernel name that all the dev links point to by using the following command. Udev ADM info hyphen name slash dev slash NVMe 0N1 hyphen query space property property dev name value slash save slash NVMe 0N1. You can also obtain the base kernel name that all the dev links point to by using the following command udev ADM info name slash dev slash NVMe 0N1 query property property dev name value slash dev slash NVMe 0N1. Udev ADM info name slash dev slash NVMe 0N1 query property property dev name value slash dev slash NVMe 0N1 slash dev slash NVMe 0N1. The kernel name and any of its dev links can be used interchangeably. You can use one of the dev links to get the full list of dev links by using the following command udev ADM info name slash dev slash this slash by ID NVMe NVMe dot 8086 6E766 D652 D31 54 51454D55204E564D652043726C hyphen 0000001 hyphen query property hyphen property there links hyphen value. So user medium info hyphen name hyphen query space property hyphen property there links value. Disk partitions. To divide a disk into one or more logical areas, use the disk partitioning utility. It enables separate management of each partition. Overview of partitions. The hard disk stores information about the location and size of each disk partition in the partition table. Using information from the partition table, the operating system treats each partition as a logical disk. Some of the advantages of disk partitioning include reduce the likelihood of administrative oversights of physical volumes, ensure sufficient backup, provide efficient disk management, additional resources. What are the advantages and disadvantages of using partitioning on LUNs, either directly or with LVM in between Red Hat knowledge base? Comparison of partition table types. To enable partitions on a device, format a block device with different types of partition tables. The following table compares the properties of different types of partition tables that you can create on a block device. This section does not cover the DAST partition table, which is specific to the IBM Z architecture. Partition table types. Partition table maximum number of partitions, maximum partition size. Master boot record MBR. Maximum number of partitions 4 primary or 3 primary and 1 extended with 12 logical partitions. 2 TAB if using 512 byte sector drives. 16 terabytes if using 4K sector drives. GUID partition table GPT. Maximum number of partitions are 128. 8 zettabyte if using 512 byte sector drives. 64 zettabyte if using 4K sector drives. Additional resources. Configuring a Linux instance on IBM Z. What you should know about DAST. MBR disk partitions. The partition table is stored at the very start of the disk before any file system or user data. For a more clear example, the partition table is shown as being separate in the following diagrams. Disk with MBR partition table. Disk MBR table unused partition file system unused. 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 As the previous diagram shows, the partition table is divided into 4 sections of 4 unused primary partitions. A primary partition is a partition on a hard disk drive that contains only one logical drive or section. Each logical drive holds the information necessary to define a single partition, meaning that the partition table can define no more than 4 primary partitions. Each partition table entry contains important characteristics of the partition, the points on the disk where the partition starts and ends, the start of the partition also as only one partition can be flagged as active, the type of partition. As the previous diagram shows, the partition table is divided into 4 sections of 4 unused primary partitions. A primary partition is a partition on a hard disk drive that contains only one logical drive or section. Each logical drive holds the information necessary to define a single partition, meaning that the partition table can define no more than four primary partitions. Each partition table entry contains important characteristics of the partition, the points on the disk where the partition starts and ends, the state of the partition as only one partition can be flagged as active, the type of partition, the starting and ending points define the size and location of the partition on the disk. Some of the operating systems bootloaders use the active flag. That means that the operating system in the partition that is marked active is booted. The type is a number that identifies the anticipated usage of the partition. Some operating systems use the partition type to denote a specific file system type, flag the partition as being associated with a particular operating system, indicate that the partition contains a bootable operating system. The following diagram shows an example of a drive with a single partition. In this example, the first partition is labeled as DOS partition type. The type is a number that identifies the anticipated usage of a partition. Some operating systems use the partition type to denote a specific file system type, flag the partition as being associated with a particular operating system, indicate that the partition contains a bootable operating system. The following diagram shows an example of a drive with a single partition. In this example, the first partition is labeled as DOS partition type, disk with a single partition, disk MBR table, primary partition is DOS, file system is FAT32, unused partition file system is unused, unused partition file system is unused, unused partition file system is unused. Primary partition is DOS, file system is FAT32, additional resources MBR partition types. Extended MBR partitions. To create additional partitions if needed, set the type to extended. To create additional partitions if needed, set the partition type to extended. An extended partition is similar to a disk drive. It has its own partition table which points to one or more logical partitions. Extended MBR partitions. To create additional partitions if needed, set the type to extended. An extended partition is similar to a disk drive. It has its own partition table which points to one or more logical partitions contained entirely within the extended partition. The following diagram shows a disk drive with two primary partitions and one extended partition containing two logical partitions along with some unpartitioned free space. This with both two primary and an extended MBR partition. Disk MBR table. Primary partition is DOS. File system is FAT32. Primary partition is Linux native. File system is XFS. Primary partition Linux native, file system is XFS. Extended partition logical partition DOS. File system FAT32. Logical partition Linux native. File system is XFS. So this is the free space. Free space. You can have only up to 4 primary and extended partitions, but there is no fixed limit to the number of logical partitions. As a limit in Linux to access partitions, a single disk drive allows maximum 15 partitions. MBR partition types. The table below shows a list of some of the most commonly used MBR partition types and hexadecimal numbers to represent them. The table below shows a list of some of the most commonly used MBR partition types and hexadecimal numbers to represent them. MBR partition type empty, value 00, DOS 12-bit FAT 01, Xenix root 02, Xenix USR 03, DOS 16-bit 32M 04, extended 05, DOS 16-bit greater than or equal to 3206, OS/2 HPFS 07, AX 08, AX bootable 09, OS/2 boot manager 0A, Win95 FAT 32 0B, Win95 FAT 32 LBA 0C, Win95 FAT 16 LBA 0E, Win95 extended LBA 0F, Phoenix 8028640, Novel 51, P Rep Boot 41, GNU Hard 63, Novel Netware 28664, Novel Netware 38665, PIC or IX 75, Old Minix 80, Linux or Minux 81, Linux Swap 82, Linux Native 83, Linux Extended 85, Amoeba 93, Amoeba BBT 94, BSTR 386, A5, OpenBST A6, NextStep A7, BSDIFS B7, BSDI Swap B8, Syrinx C7, CP/M DB, DOS Access E1, DOS R/O E3, DOS Secondary F2, BBT FF, GUID partition table. The GUID partition table GPT is a partitioning scheme based on the globally unique identifier GUID partition table. The GUID partition table GPT is a partitioning scheme based on the globally unique identifier GUID. GPT deals with the limitations of the master boot record MBR partition table. The MBR partition table cannot address storage larger than 2 TB. So cannot address storage larger than 2 TB bytes, equal to approximately 2.2 terabyte. So TB byte the system is the base 2 and terabyte system is base 10. Instead, the GPT supports hard disks with larger capacity. The maximum addressable disk size is 8 ZB bytes when using 512 byte sector drives and 64 ZB byte when using 4096B sector drives. In addition, by default, GPT supports creation of up to 128 primary partitions. Extend the maximum amount of primary partitions by allocating more space to the partition table. Extend the maximum amount of primary partitions by allocating more space to the partition table. Note: a GPT has partition table types based on GUIDs. Certain partitions require a specific GUID. For example, the system partition for extensible firmware interface EFI bootloaders require GUID C12A732881F 11T2 BA4B 00A0 C93C93B. GPT use logical block addressing LP and a partition layout as follows. GPT disuse logical block addressing LBA and a partition layout as follows. For backward compatibility with MBR disk, the system reserves the first sector LBA0 of GPT for MBR data and applies the name protective MBR. Primary GPT, the header begins on the second logical block LBA1 of the device. The header contains the disk GUID, the location of the primary partition table, the location of the secondary GPT header, and CRC32 checksums of itself and the primary partition table. It also specifies the number of partition entries on the table. By default, the primary GPT includes 128 partition entries. The primary GPT includes 128 partition entries. Each partition has an entry size of 128 bytes. A partition type GUID and a unique partition GUID. Secondary GPT. By default, a primary GPT includes 128 partition entries. Each partition has an entry size of 128 bytes. A partition type GUID and a unique partition GUID. Secondary GPT. For recovery, it is useful as a backup table in case the primary partition table is corrupted. It is useful as a backup table in case the primary partition table is corrupted. The last logical sector of the disk contains a secondary GPT header and recovers GPT information in case the primary header is corrupted. It contains a disk GUID, the location of the secondary partition table and the primary GPT header. It contains a disk GUID, the location of the secondary partition table and the primary GPT header. CRC32 checksums of itself. CRC32 checksums of itself, the secondary partition table, the number of possible partition entries. The number of possible partition entries. Disk with a GUID partition table, disk GPT table, disk with a GUID partition table, disk GPT table, GPT partition, GUID basic data, file system FAT32 GPT partition GUID root. File system is XFS. GPT partition GUID home. File system is XFS. Free space. Important for a successful installation of the bootloader onto a GPT disk, a BIOS boot partition must be present. So important for a successful installation of the bootloader onto a GPT disk, a BIOS boot partition must be present. Reuse is possible only if the disk already contains a BIOS boot partition. This includes disk initialized by the Anaconda installation program. Partition types. There are multiple ways to manage partition types. The fdisk utility supports a full range of partition types by specifying hexadecimal codes. The parted utility maps out the partition type with flags. Before that, the systemd-gpt-auto-generator, a unit generator utility, uses the partition type to automatically identify and mount devices. The parted utility maps out the partition type with flags. The parted utility handles only certain partition types, for example, LVM, swap, or RAID. The parted utility supports setting the following flags: boot, root, swap, hidden, RAID, LVM, LBA, legacy underscore boot, IRST, ESP, follow. On Red Hat Enterprise Linux 9 with Parted 3.5, you can use the additional flags Chrome OS underscore kernel and PLS underscore boot. On Red Hat Enterprise Linux Line with Parted 3.5, you can use additional flags Chrome OS underscore kernel and BLS underscore boot. The parted unity optionally accepts a file system type argument while creating a partition. For a list of the required conditions, see creating a partition with parted, use the value to set the partition flags on MBR. Set the partition flags on MBR. Set the partition UUID type on GPT. For example, the swap, PAT or HFS file system type set different GUIDs. The default value is the Linux data GUID. The argument does not modify the file system of the partition, it only differentiates between the supported flags and GUIDs. The following file system types are supported: XFS, ext2, ext3, ext4, FAT16, FAT32, HFS, HFS plus, Linux swap, NTFS, RazorFS. Partition naming scheme. The Red Hat Enterprise Linux uses a file-based naming scheme with file names in the form of /save/xxxyn. Device and partition names consist of the following structure. Partition naming scheme. Red Hat Enterprise Linux uses a file-based naming scheme with file names in the form of /save/xxyn. Device and partition names consist of the following structure. /save/ name of the directory that contains all device files. Hard disk contain partitions, thus the files representing all possible partitions are located in /save. Partition naming scheme. Red Hat Enterprise Linux uses a file-based naming scheme with file names in the form of /save/xxyn. Device and partition names consist of the following structures: /save/name of the directory that contains all device files. Hard disk contain partitions, thus the files representing all possible partitions are located in /save. Red Hat Enterprise Linux uses a file-based naming scheme with file names in the form of /save/xxyn. Device and partition names consist of the following structures: /save/name of the directory that contains all device files. Hard disk contain partitions, thus the files representing all possible partitions are located in /save. XX. The first two letters of the partition name indicate the type of device that contains the partition. The type of device. This letter indicates a specific device containing the partition. For example, /save/STA for the first hard disk and /save/STB for the second. You can use more letters in systems with more than 26 drives. For example, /save/STAA1. The first two letters of the partition name indicate the type of device that contains the partition. /save/name of the directory that contains all device files. Hard disk contain partitions, thus the files representing all possible partitions are located in /save. XX. The first two letters of the partition name indicate the type of device that contains the partition. Name of the directory that contains all device files. Hard disk contain partitions, thus the files representing all possible partitions are located in /save. The first two letters of the partition XX. The first two letters of the partition name indicate the type of device that contains the partition. Y. This letter indicates the specific device containing the partition. For example, /save/STA for the first hard disk and /save/STB for the second. You can use more letters in systems with more than 26 drives. For example, /save/STAA1 N. The final letter indicates the number to represent the partition. The first four primary or extended partitions are numbered 1 through 4. Logical partitions start at 5. For example, /save/STA3 is the third primary or extended partition on the first hard disk, and /save/STB6 is the second logical partition on the second hard disk. Second logical partition on the second hard disk drive. Partition numbering applies only to MBR partition tables. Note that n does not always mean partition. Drive partition numbering applies only to MBR partition tables. The final letter indicates the number to represent the partition. The first four primary or extended partitions are numbered 1 through 4. Logical partitions start at 5. For example, /save/st3 is the third primary or extended partition on the first hard disk, and /save/stp6 is the second logical partition on the second hard disk. Drive partition numbering applies only to MBR partition tables. Note that n does not always mean partition. Note even if Red Hat Enterprise Linux can identify and refer all types of disk partitions, it might not be able to read the file system and therefore access stored data on every partition type. However, in many cases, it is possible to successfully access data on a partition dedicated to another operating system. Mount points and disk partitions. In Red Hat Enterprise Linux, each partition forms a part of the storage necessary to support a single set of files and directories. Mounting a partition makes the storage of that partition available starting at the specified directory known as a mount point. For example, if partition /save/st5 is mounted on /usr, it means that all files and directories under /usr physically reside on /save/sta5. The file /usr/share/doc/faq/txt/linux-faq usr share doc faq txt linux-faq resides on /save/sta5, while the file /etc/gdm/custom.conf does not. /etc/gdm/custom.conf does not. Continuing the example, it is also possible that one or more directories below /usr would be mount points for other partitions. One or more directories below /usr would be mount points for other partitions. For example, /usr/local/man/whatis resides on /save/sta7 rather than on /save/sta5 if /usr/local includes a mounted /save/sta7. Chapter 4, Getting Started with Partitions. Use disk partitioning to divide a disk into one or more logical areas, which enables work on each partition separately. The artist stores information about the location and size of each disk partition in the partition table. Using the table, each partition then appears as a logical disk to the operating system. You can then read and write on those individual. Chapter 4, Getting Started with Partitions. Use disk partitioning to divide a disk into one or more logical areas, which enables work on each partition separately. The hard disk stores information about the location and size of each disk in the partition table. Using the table, each partition then appears as a logical disk to the operating system. You can then read and write on those individual disks. For an overview of the advantages and disadvantages of using partitions on block devices, see the Red Hat knowledge base solution. What are the advantages and disadvantages of using partitions on LUNs, either directly or with LVM in between? Create a partition table on a disk with parted. Use the parted utility to format a block device with a partition table more easily. Warning: formatting a block device with a partition table deletes all data stored on the device. Procedure: start the interactive parted shell. Start the interactive parted shell parted space block device. Determine if there is already a partition table on the device using print. So parted /save/nvme0n1 N1. Part 8 with part 8 slash save slash NVMe 0 N1. Part 8 slash save slash NVMe 0 N1. Determine if there already is a partition table on the device using the print command. Determine if there already is a partition table on the device using the print command. Print. Partition table is already present on the device. So the type of file system here is XFS. First one is FAT32. Second, third, and fourth one are XFS file systems. Fifth one is Linux swap. Linux swap file system. You can see the flags for the first one FAT32 EFI system partition boot and ESP. Boot and ESP are the flags. For Linux swap is the flag. If the device already contains partitions, they will be deleted in the following steps. Create the new partition table mk label space table type mk label. Create the new partition table mk label space table type. Replace table type with the intended partition table type mk label. Make label space table type. Create the new partition table MS-DOS for MBR and GPT for GPT. Creating a GOID partition table type GPT table. To create a GPT table on the disk, use mk label space GPT. mk label space GPT. mk label space GPT. Partitions on slash save slash NVMe 0 in 1 are being used. Ignore the existing disk label on slash save slash NVMe 0 in 1 will be destroyed and all data on this disk will be lost. Do you want to continue? No. So it has come back. So part 8 slash save slash NVMe 0 N1 P1 sorry P3 parted space block device. Determine if there is already a partition table on the device. So GNU parted 3.5 using slash save slash NVMe 0 in 1 P3. Welcome to GNU parted. Print command. So 42.969 GB 0 bytes to 42.99 GB. Size is 42.9 GB. File system is XFS. File system is XFS. If the device already contains partitions, they will be deleted in the following steps. So print, create the new partition label mk label space table type. Replace table type with the intended partition table type. GPT for GPT, MS DOS for MBR. Creating a partition table on a disk with parted space block device. Parted //stc. Determine if there already is a partition table on the device using the print command. So it's partition table unknown. Partition table is unknown. Disk is //stc. VMware Virtual SCSI disk. Error //stc unrecognized disk label. So it doesn't have a disk label. Partition table is unknown. And no disk flags. If the device already contains partitions, they will be deleted in the following steps. So if I execute this step, it will delete all the partitions if the device already contains partitions. So I'm using a fresh disk. Create the new partition table, mk label space table type. So table type can be replace table type with the intended partition table type. MS DOS for MBR, GPT for GPT. Creating a GUID partition table, GPT table. To create a GPT table on the disk, use mk label space GPT. So use mk label space GPT. Use the print command again. Now it says partition table is GPT. See, earlier there was no partition table. Partition table is unknown. Now it is showing me the partition table. Partition table is GPT. Partition table is GPT. The changes start applying after you enter this command. View the partition table to confirm it is created. Print command, exit the parted shell. Quit. Exit the parted shell. Quit. So parted //stc print. So now partition table is GPT. Partition table is GPT. Quit. Viewing the partition table with parted, display the partition table of a block device. To see the partition layout and details about individual partitions, you can view the partition table on a block device using the parted utility. Procedure: start the parted utility. For example, the following output lists the device /save/sta. Parted /save/sta. View the partition table. Print. Switch to the device you want to examine next. Select block device. Select the block device. parted slash save slash stc print command. So it says model disk sector size partition table disk flags number start end size file system name flags. Optional switch to the device you want to examine is select the block device. For a detailed description of the print command output, see the following model ATA Samsung MZNL N256G. The disk type, manufacturer, model number and interface. The disk type, manufacturer, model number and interface. Disk slash save slash STA256 GB. The file path to the block device and the storage capacity. The file path to the block device and the storage capacity. The file path to the block device slash save slash STC and the storage capacity is 10.7 GB. Partition table is MS-DOS. The disk label type. The disk label type. Here partition table is GPT. The disk label type is GPT. Number. The partition number. For example, the partition with binary number 1 corresponds to slash save slash STA1. The partition number, for example, the partition with minor number 1 corresponds to slash save slash STA1. So this is the minor number. This one, this is the minor number. So this corresponds to slash save slash STA1 start and end. Partition table is MS-DOS, the disk label type. Number, the partition number, for example, the partition with minor number 1 corresponds to slash save slash STA1. So it is slash save slash STA. So this is minor number 1. So this is slash save slash STA1. Minor number 1. Minor number 1 slash save slash STA1 start and end. The location on the device where the partition starts and ends. Start and end the location on the device. The location on the device where the partition starts and ends. The location on the device where the partition starts and ends. Type. Value types are metadata, free, primary, extended or logical. Value types are metadata. Value types are metadata. Value types are metadata, free, primary, extended or logical. Free. Start and end the location on the device where the partition starts and ends. The location on the device where the partition starts and ends. Type. Value types are metadata, free, primary, extended or logical. File system. The file system type. If the file system field of a device shows no value, this means that its file system type is unknown. The parted utility cannot recognize the file system on encrypted devices. Flags. List the flags set for the partition. Available flags are boot, root, swap, hidden, RAID, LBM or LBA. Additional resources. Parted man page on your system. Creating a partition with parted. As a system administrator, you can create new partitions on a disk by using the parted utility. A partition prerequisites. A partition table on the disk. If the partition you want to create is larger than 2 TB, format the disk with the GOID partition table GPT. Prerequisites. A partition table on the disk. If the partition you want to create is larger than 2 TB, format the disk with the GOID partition table GPT. Procedure. Start the parted utility parted, space, block device. Parted space 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 block devi Parted space block device. View the current partition table to determine if there is enough free space. Print. So parted slash save slash stc and then print command. Resize the partition in case there is not enough free space. Format the partition table. Determine from the partition table. Determine the start and end points of the new partition. On MBR, what partition type it should be. From the partition table, create the new partition MK part type, name, FS type, start, end. Replace part type with the primary, logical, or extended. This applies only to the MBR partition table. Primary, logical, or extended. This applies only to the MBR partition table. Replace name with an arbitrary partition name. This is required for GPT partition tables. Arbitrary partition tables. Arbitrary partition name. Replace FS type with XFS, EXT2, EXT3, EXT4, FAT16, FAT32, HFS, HFS plus Linux swap, NTFS or Riser FS. The FS type parameter is optional. Note that the parted utility does not create the file system on the partition. Does not create the file system on the partition. Replace start and end with the sizes that determine the starting and ending points of the partition counting from the beginning of the disk. You can use size suffixes such as 512 MB, 20 GB or 1.5 TB. The default size is in megabytes. Creating a small primary partition. To create a primary partition from 1024 MB until 2048 MB on an MBR table. MK part primary 1024 MB 2048 MB. Creating a small partition, primary partition. So MK part partition type is primary. Name. This is required for GPT partition tables. And file system type. File system type XFS start and end. MK part primary. MK part primary 1024 MB to 2048 MB. MK part primary 1024 MB to 2048 MB. The changes start applying after you enter the command. The changes start applying after you enter the command. View the partition table to confirm that the created partition is in the partition table with the correct partition type, file system type and size. So it is executed now. View the partition table to confirm that the created partition is in the partition table with the correct partition type, file system type and size. View the partition table to confirm that the created partition is in the partition table. View the partition table to confirm that the created partition is in the partition table with the correct partition type, file system type and size. So type the print command. MK part primary 1024 MB 2048 MB. Print command. So file system type is not given. Delete partition number. Print. Delete slash stc1. It is just rm space 1. Rm space 1 to remove the partition, and print command remove the partition. Print command remove the partition. So rm space 1 remove the partition. So mk part partition type primary file system type and then start end. Mk part primary mk part partition type is primary name file system type name is first partition type of file system is xfs and start end 1024 MIB 2048 MIB invalid token file system type ext2 xfs starting cylinder 1024 MIB end 2048 MIB print. So remove the first partition. I'll recreate it. MK part make partition primary XFS file system 1024 MIB 2048 MIB print command. So now I created a partition here. And then quit command, exit the parted shell using the quit command. Using the quit command, and then register the new device node udev adm settle udev adm settle udev adm settle udev adm settle, and then verify that the kernel recognizes the new partition. Verify that the kernel recognizes the new partition. Cat slash proc slash partitions cat slash slash proc slash partitions cat slash proc slash partitions. So stc1 kernel recognizes the new partition stc1. Kernel recognizes the new partition stc1. Additional resources: parted man page on your system, creating a partition table on a disk with parted, resizing a partition with parted, setting a partition type with fdisk. You can set a partition type or flag using the fdisk utility. Partition type or flag. Prerequisites: a partition on the disk. Start the interactive fdisk shell fdisk space block device. Start the interactive fdisk shell fdisk space block device. Fdisk place slash save slash stc. View the current partition table to determine the minor partition number. View the current partition table to determine the minor partition number. Use the print command. Minor partition number is 1 STC1. This is the minor partition number. Size is 1 GB, 1 GB. You can see the current partition type in the type column and its corresponding type ID in the ID column. Current partition type is Linux file system. Current partition type is Linux file system. Partition type. You can see the current partition type in the type column. Current partition type in the type column. Here it is Linux file system and its corresponding ID in the ID column. There is no ID column here, but you can see the partition type in the type column. Enter the partition type command and select a partition using its minor number. Enter the partition type command. Type and select a partition using its minor number. So select a partition using its minor number. Enter type. Partition type or alias. Type capital N to list all. Selected partition 1. Already it is selected partition 1. Partition number is 2. Already it is selected. View the list in hexadecimal codes. View the list hex codes. Capital L. View the list in hexadecimal codes. All these are the type of partitions. You can also use the aliases Linux swap home EU UEFI RAID LVM. Select the partition type. Hex code is 80. What is 80? Eighty. Write your changes and exit the fdisk shell. 80 is Linux LVM. 80 is Linux LVM. 80. Type of partition 1 is unchanged Linux file system. So it is Linux file system. So there is no 80 in RHEL 9.5 actually. First type. I will use LVM itself directly. So change the type of partition from Linux file system to Linux LVM. So LVM is here, Linux file system to Linux LVM. Write your changes and write your changes and exit the fdisk shell. Write command. The partition table has been altered calling IOCTL function syncing this. The partition table has been altered syncing this. Verifier changes fdisk hyphen list block device. Fdisk hyphen list block device /save/stc. You can see now it is Linux LVM. Earlier it was Linux file system. Now it is Linux LVM. Resizing a partition with parted. Using the parted utility, extend a partition to use unused disk space. Extend a partition to use unused disk space or shrink a partition to use its capacity for different purposes. Prerequisites: back up the data before shrinking a partition. Back up the data before shrinking a partition. Resizing a partition with parted. If the partition you want to create is larger than 2 TB, format the disk with the GUID partition table GPT. If the partition you want to create is larger than 2 TB, format the disk with the GUID partition table GPT. If you want to shrink the partition, first shrink the file system so that it is not larger than the resized partition. If you want to shrink the partition, first resize the file system so that it is not larger than the resized partition. XFS does not support shrinking. XFS does not support shrinking. Start the parted utility. Parted space block device. Print view the current partition table. Parted /save/stc. Print view the current partition table. From the partition table, determine the minor number of the partition. Locate the location of the existing partition and its new ending point after resizing. The location of the existing partition and its new ending point after resizing. Resize the partition. Resize part 1 space 2 GIB. Replace 1 with the minor number of the partition that you are resizing. Replace 2 with the size that determines the new endpoint of the resized partition counting from the beginning of the disk. You can use size suffixes such as 512 MB, 20 GB or 1.5 TB. The default size is in the megabytes. Default size is in megabytes. View the partition table to confirm that the resized partition is in the partition table with the correct size. Print. Exit the parted shell. Quit. So resize part 1 is the minor number of the partition that you are resizing and the new size. Replace 2 with the size that determines the new ending point of the resized partition. New ending point of the resized partition. Counting from the beginning. Counting from the beginning. Counting from the beginning of the disk. You can use size suffixes such as 512 MB, 20 GB or 1.5 TB. The default size is in megabytes. View the partition table to confirm that the resized partition is in the partition table with the correct size. 2, 2. So the size was 1 GB if you remember. The size was 1 GB earlier. I am resizing it to 2 GB. 1 GB. Earlier it was 1 GB. Now I am resizing it to 2 GB bytes. 2 GB bytes. 2 GB bytes. Resize partition. This is the minor number. Resize part. Minor number ended 2 GB bytes. View the partition table to confirm that the resized partition is in the partition table with the correct size. Print command. Print command. Okay, ending I must extend it. Earlier it was 2147 MB. Now spreadsheet resize part 1 3 GB bytes. Print. I can see it is extended. The size increased to 2 GB. 2 GB, and the ending cylinder ending size I've extended it to 3 GB. 3221 MB. Exit the parted shell. Quit. Verify that the kernel registers the new partition. View the medium settle cat slash proc slash partitions SDC1. So now the size has increased to 2 GB byte. The size has increased to 2 GB byte. 2 GB. If you extended the partition, extend the file system on it as well. Optional. We extended the partition, extend the file system on it as well. Removing a partition with parted. Using the parted utility, you can remove a disk partition to free up disk space. Removing a partition deletes all data stored on the partition. Start the interactive parted shell. Parted space block device /save/stc. Replace block device with the path to the device where you want to remove a partition. Replace block device with the path to the device. Block device with the path to the device where you want to remove a partition. For example, /save/sta. Start the interactive parted shell. Replace block device with the path to the device where you want to remove a partition. For example, /save/sta. View the current partition table to determine the minor number of the partition to remove. View the current partition table to determine the minor number of the partition to remove. Print command. Minor number of the partition to remove 1. Remove the partition rm space minor number. Rm space minor number. Rm space minor number. Rm space 1. Replace minor number with the minor number of the partition you want to remove. The changes start applying as soon as you enter this command. Verify that you removed the partition from the partition table using the print command. Remove the partition from the partition table using the print command. Exit the parted shell. Quit. View the medium settle cat slash proc slash partitions. So SDC1 is removed now. SDC1 is removed. Remove the partition from the etc file if it is present. Find the line that declares the removed partition and remove it from the file. Find the line that declares the removed partition from etc file if there is any entry, and remove it from the file. There are no entries actually, as I did not make any entries in etc file. cat slash etc slash fs tab file. There is no entry for e slash stc slash n slash stc1. Regenerate mount units so that your system registers the new etc step configuration. So systemctl daemon reload regenerates mount units so that your system registers the new etc step configuration. Systemctl daemon reload. If you have deleted a swap partition or removed pieces of LBM, remove all references to the partition from the kernel command line. If you have deleted a swap partition or removed pieces of LBM, remove all references. List all kernel options and see if any option references the removed partition. Any option references the removed partition. If you have deleted a swap partition or removed pieces of LBM, remove all references to the partition from the kernel command line. List active kernel options and see if any option references the removed partition. Grub -info is equal to all. Grubby. Grubby -info is equal to all. Index index 1, index 0, kernel /boot /vm linux hyphen 5.14.0 hyphen 503.11.1.el 9 underscore 5.x86 underscore 64 arguments. Read only clash kernel is equal to 1 GB to 4 GB. 192 M, 4G to 664G, 256 M, 64G to 112 M. Resume UUID RSGB quiet. Root is equal to UUID is equal to the UUID init is equal to /boot /initramfs hyphen 5.14.0 hyphen 503.11.1.el9 underscore 5.x86 underscore 64.ng dollar tuned underscore init rd. Title is equal to double quote edit enterprise linux 5.14 9.5 flow. ID is equal to index is equal to and kernel is equal to /boot /vm linux hyphen 0 hyphen rescue. So this is 5.14. This is Linux 0 hyphen rescue. Arcs is equal to only crash kernel is equal to resume is equal to Remove the kernel option that reference the removed partition. Maybe hyphen update hyphen kernel is equal to all hyphen remove hyphen arcs is equal to option. To register the changes in the early boot system, rebuild the anytime FS file system. Register the changes in the early boot system, rebuild the anytime FS file system. Drag code hyphen force hyphen verbose. Drag code hyphen force hyphen verbose.